We're going to start with categorical data. There's a lot of ways that we can visualize categorical data. One of my favorites is alluvial or Sankey diagrams. These show the flow between two or more categorical variables, sometimes over time. It's really useful for showing how different groups change over time, but otherwise it looks just like a bar chart with connecting lines, so it's not incredibly confusing or new for people. Tree maps are used to show hierarchical relationships where the categories are nested within one another. This is a fairly simple looking graph that can hold a lot of information for your audience. Mosaic plots are similar to tree maps, but they are essentially cross tabulations visualized. So if you are thinking of a cross tab table, mosaic plots essentially visualize that. For the setup, of course, we're going to use tidyverse and gapminder data here. For alluvial and Sankey diagrams, like we mentioned, we're going to use a GG alluvial package. To get the data prepared for this, we're going to semi-artificially create another categorical variable that we can use. This one, we're going to use this code right here with a case when statement. What this is saying is we're going to create a new variable called type. And when population is greater than 1 times 10 to the 8 or 1e8, then give it the label 100 plus million. When the population is greater than 1e7, give it this label, etc. And then the last one, if it doesn't fit any of these other conditions, then do less than 1 million. We then use this data to group by. So we're going to get, for every year and continent and type, we're going to get the number of distinct countries in those groupings. After that, we're going to then get some information by year. First is we're going to get a row number. These are things that help the plot know what things are moving around from one year to another. We're going to clean up the type variable by putting it in an order that we want it to. So if we didn't touch this up, it would put it in the order alphabetically for our labels. But here we want to change those to start with this one, move to this, etc. Lastly, we're just going to grab 3 of the years. The very first year, year in the middle, and then the last year. And then we're going to do a year categorical variable. And that is just going to be essentially changing our continuous year variable into a factor. If we print this out, we can see for Africa, we have a country that, or 32 countries that have 1 million or more. We have 5 with 10 million or more, both of these being in 1952. And each of these have an ID. So we know that this is groups that go together for this plot. Now, setting up your data for an alluvial plot, it's best if you can do something like this. You're given it counts by certain grouping variables. And those counts are what ultimately is going to inform it where things are moving and when. Using that data, we're going to use a couple of aesthetics. The first, we're going to say our x-axis is the year, but the categorical version of year. Our y-axis is going to be the n, so that's going to be the counts. So if we ignore the rest of this, up to this point, this is kind of looking like a GM call, COL type plot. we're essentially making a bar graph at this point. The next thing that we're giving it is the stratum, which in our case is the type. And if we go back to the data, you can see type is our grouping, our color, what we really want to show, like the groupings that are changing over time. So that's our stratum. And then our alluvium is going to be our identifier. And if you remember this one, that is for every continent and grouping over time. So what we told it is our x-axis is this. These all go together across the x-axis. Next thing we're going to use is geom_flow. And we're going to tell it the coloring that we want it to fill in with is by type. And then we do geom_stratum, which is going to be alpha equals 0.8, so 20% transparency. And the color, which if you remember, we're saying color when it's a 3D or a 2D object. That's going to be the outline. If it's just a line, then it's going to be the color of the line. So for the geom_stratum, that is the boxes that you're going to see here. That's essentially our bar graph. And so the outline of it, we want it to be dark gray. The last thing we want to add is our geom_text. This one is special for the geom_alluvium or the geom_flow and stratum. This functionality, you're not going to use stat equals stratum very often, but for this package, it's what's going to tell it where to put the text. And then we also add an aesthetic. In this case, it's the label that we want the geom_text to put in there, and we want it to be the type, which if you remember, that is the population size. So these three lines right here are basically giving us the flow. So the colors going from one bar to the other, it's creating the bars, and it's adding a label to the text in that order. So the flow is going to be behind the bars, and the text is going to be on top of the bars. The last three lines are just aesthetic things. We're going to use theme minimal, which gets rid of most of the background information other than the panel grid. And then we use scale fill viridis for a default color palette that I like. And then we're given some labels. So let's see what this looks like. So what we're seeing immediately is that on the x-axis we have 1952, 1982, and 2007, as we expected. Number of countries is our y, which was our n that we created in our data set. In 1952, this was the distribution of the population sizes. Very few countries were over 100 million. Then we have the change from this one to this year. And here we're seeing most countries are moving up in some way. So about a third maybe of those that were really small are now above 1 million. Maybe about half of the 1 million are now going into the 10 million. And some of the 10 plus million are going into the 100 million. And we continue to see this through all of these different plotting techniques. Now you'll notice there's some outlying lines, and this plot is really awesome because it's giving you some clues. Okay, there's some that are really surprising. I wonder what happened there. And so there's probably a country that we'd want to take a look at. Why did it shrink so much from 1952 to 1982? And then we conversely have some countries from 1982 that jump up massively from really small to really large. This figure gives us a lot of information that we can then go investigate further. Now for a tree map, we're going to be using the tree mapify package, and we're going to use Gapminder again. In this case, we're just going to filter Gapminder to the year 2007. We're going to use the AS of area, and that's going to be equal to the population size, and we're going to color in the boxes by continent. We're going to use geom map. That is going to give us our initial boxes together. And then we're going to use geom map text in order to put in the country label within the text. So we're going to say label equals country. Color is white. We want the place to be centered in the box for the label. And then the grow equals true means we want the text to fit the box and get bigger and bigger as the box is bigger. So we can see here, this is what it produces. Very clearly we can see that Asia, the color of India and China and several others, generally has the largest countries in the year 2007, including India and China. We also can see the Americas has some countries that are relatively large, including the United States, Brazil, Mexico. Importantly, what we're visualizing here is a continuous variable. It's population size. But what we could also visualize here are other categorical variables as well. It doesn't have to be a continuous variable underlining the size of the boxes. But in this case, it was an easy one to be able to show what TreeMapify is going to do. Our last example for categorical related data is the mosaic plot. This one, again, we're going to create some artificial categorical variables. We're going to use the same one we did previously with type, which is the population size as a categorical variable. And then we're also going to create life expectancy as a categorical variable. And we're going to grab our final year of data. So here we are just creating some mostly unnecessary categorical variables, but it's going to be very useful for our mosaic plot. In the end, this is what it looks like, where we have country, continent, year, life expectancy, population, GDP, and then our new variables type. And it got moved over here, but life category is here, low and high. So now we actually can make the mosaic plot using that data. We first load the GG mosaic package. In this case, we're not giving any aesthetics directly to ggplot. Instead, we're just going to hand them directly to geom mosaic. We don't have to do this, but I highlight it here as it's a possibility for you to always call out your aesthetics directly in your geoms, or you can do it more broadly across all your geoms if you do it in ggplot itself. Here, I do it here because we're doing something a little special. We're doing the product of type, which is something that Mosaic provides for us in order to do the right sizing of the type variable on the x-axis. And then the other argument we give is fill. In this one, it's going to be the life category, and it's going to interpret this in geom mosaic as roughly the y-axis, but it's a y-axis that adjusts based on what is in that fill. We're removing our legend. We're going to use theme mosaic as it looks nice, and then some manual colors for our fill. What this produces is essentially a cross tabulation where we get to see the proportion of countries that fit into each category as the area that we're seeing in each of these boxes. So countries that are less than 1 million in population size, the majority of those have high life expectancy. About maybe 30% of those are in low. But there's also not a whole lot of countries that fit that. That's a pretty small bar. There's a lot more countries in the 1+ million and the 10+ million groups.